and welcome to today's seminar, Materializing E-Mobility Ambitions, being presented by BASF and hosted by AMCO Polymers. My name is Robert Nelson, and I am the Mobility Growth Leader from AMCO Polymers, and with me as well is Bruce Serafin, our Mobility Segment Leader at AMCO. You can go to the second slide. Give you a little bit of time to read and look at this page, but I also wanted to let you know that if you have any questions, please log them in through the session, as at the end we'll have time and we'll answer as many of your questions as we can. And if we do not get to your question today, we'll be very happy to answer that via email after the seminar. I'll go to slide 3. At this time, it gives AMCO Polymers great privilege to introduce to you our presenters and partners from BASF. Today we have Edna Betancourt, who is responsible for segment management of EE and Mobility Industrial, Viraj Shah, who is responsible for segment management of EE and Mobility Transportation, and Adam Marcinkowski, who is responsible for application development in the EE segment. Now I'd like to turn it over to Edna, Viraj, and Adam for today's presentation.
All right, so in the interest of saving bandwidth, we're going to turn our cameras off so we don't run into any technical hitches here. All right, everyone, so good afternoon. Thank you very much for taking the time out of your busy days to meet with us here. We're really excited to go over the e-mobility market as a whole, and then also talk about how BASF is involved in the market, and what types of products we offer, services we offer, and product development is taking place at BASF. So the automotive industry has undergone a transformation over the last decade. While emission regulations have become increasingly stringent for ICE vehicles, internal combustion engine vehicles, the need for EVs to replace ICEs has been well documented, and consumer confidence has increased since more EVs have begun to be introduced to the market. We all remember the first EVs that were released. Since then, there has been an exponential change and growth of the EV market, which is still expected to occur. Of course, safety and performance are of utmost priority to customers, and these requirements have led to increasing regulation, while there wasn't really much in the past, since this is a relatively new market. The traditional ICE market had about a 100-year runway on the EV market, and until the EV1 was released back in the late 2000s, there really weren't any standards or anything that needed to be met by these EV manufacturers. So global governments are still developing the standards, and kind of a moving target at this point still, which I'm sure you're all well aware about. While I wouldn't say that the EV market is mature at this point by any means, the primary objective for EV manufacturers when launching their first few models is reliability and safety. So metals were selected for the quote-unquote first generation of EVs because the industry has almost 100 years of experience with metal. Metals are well known. Metallurgy is entrenched in the automotive industry. However, metals are inherently heavy and result in higher vehicle weights. Now more than ever, reducing vehicle weight has become a major priority, since weight of the vehicle directly correlates to range of the vehicle. The increasing use of plastic and composites in vehicles and phasing out the use of conventional steel and metals is where BASF sees the most opportunity for business growth. In the end, lower weight equals greater range equals less consumer range anxiety. Government regulation has significantly impacted the adoption of EVs in North America, which is the region we're focused on at this time. I'm sure we've all heard that APAC and the EU are somewhat ahead of us in terms of EV development and adoption. but we're catching up. Government regulation has helped that. If you own an EV, you're probably aware that there's a tax credit at this time that the government offers of up to $7,500 for purchasing a qualified EV, under the tax system. Currently, there is a cap of 250,000 vehicles per manufacturer, so that means Tesla or Volkswagen or Ford, up to 250,000 vehicles sold, consumers are able to get that tax benefit. However, above that, the tax benefit goes away. There is a bill in Congress that is seeking to raise the manufacturer's cap to 500,000 or 600,000 vehicles as eligible for this tax credit. And Tesla is, of course, approaching the limit at this time because of the total number of vehicles that they've sold. And clearly, they're doing a great job of promoting and selling their vehicles. In addition to that, the Senate Finance Committee in May 2021 passed a bill called the Clean Energy for America Act as part of the $1.2 trillion infrastructure bill, which would increase the rebate from $7,500 to $12,500 per vehicle for those vehicles assembled in the U.S. by union workers. So as long as it's coming out of a union plant, this bill says that each vehicle would be eligible for a $12,500 rebate. However, the vote in the Senate Finance Committee was right down the middle, 14-14, and it passed the committee and is now on the desk of the Senate. However, since May 2021, there has been no resolution to this bill. At this time, there's still been no vote, and we're still waiting on a decision vote in the Senate. In addition to the tax credit for full BEVs, there are tax credits available for plug-in hybrid vehicles as well, and the magnitude depends on the vehicle that is in question. So there's a lot of information on this slide, and so feel free to read through this as you see fit. But I'll just go through a few different major points on this slide, as well as some information that's not included in here as well. So the U.S. OEMs, the U.S.-based OEMs, in addition to the European OEMs and Asian OEMs, are clearly increasing investment in EVs and have challenging targets to meet, as you can see on this slide. The targets are many of the targets are self-imposed, but government subsidies help promote these targets, and we've seen billions of dollars of investment publicly announced by all of the major automotive manufacturers. Most of the automotive OEMs outside of Tesla are partnering with large battery manufacturers to produce, whether it's to produce full battery packs, whether it's to produce cells, or whether it's just to consult and potentially create a joint venture with each of these OEMs. The major battery manufacturers are SK Innovation, LG Chem, Samsung SDI, and Panasonic, all of whom have committed to building battery manufacturing plants in North America. There have been announcements in the past 1 year of 13 multi-billion-dollar battery pack plants in North America, and that just shows that the investment is coming, and that mass adoption is right around the corner. So GM is working with LG Chem. GM's challenging target is 25 models by 2025, and their goal is to have 1 million EVs, full BEVs, sold per year globally by 2025. Ford is in a joint venture with SK Innovation, and they have the feather in their cap as the first U.S. OEM to market with a full-size EV sedan and a full-size EV truck. Tesla is clearly, ahead of the curve compared to everyone else. They're working with Panasonic for their battery cell manufacturing and moving overflow battery pack construction out of house. They are changing the cell type to have more energy dense battery packs, And gigafactories in Berlin, Shanghai, and of course now Austin have opened and are ramping up. Tesla is looking to expand their footprint in the battery materials supply chain as well, to essentially not be beholden to raw material suppliers in the battery materials space. Stellantis has worked with CATL in the past, and they're moving forward with Samsung SDI as their major battery pack supplier. Stellantis's goal is that every model sold in North America will have a BEV version by 2025. This slide shows just general global trends in the battery electric vehicle market, and we can relate this to where we may be able to grow in the polymers market. So with evolving e-mobility trends, opportunities for polymers and composites are increasing significantly. Since the automotive market sees a transformation from conventional vehicles to hybrid and hybrid vehicles to electric vehicles, 90% of the automakers have announced hybridization milestones that essentially is I don't want to say stopgap, but is the transition period between full ICEs and full BEVs. However, as I indicated, the shift to EVs will not happen overnight like the flip of a switch. It's just too challenging to do that. Battery plants need to come online. EV assembly plants need to come online. The North America and global electrical grid system needs to be improved in order to sustain the load that half of all vehicles being BEVs will put on the grid when charging. And so the transition period of hybrids really taking over from pure ICEs is kind of the period that we're entering right now. And we'll gradually move towards mass adoption of EVs. Really, 2030 is when we expect the shift that's happening now from ICEs to hybrids to happen from hybrids to BEVs. But that being said, Toyota, Honda, Hyundai, Kia, and Mazda are all investing in plant expansions to their hybrid vehicle plants. So they clearly see there is an opportunity with hybrid vehicles. And with hybrid vehicles, there's more plastic content than just ICEs or just BEVs, which, if you have any questions about that, please feel free to ask us. So in 2020, and we're still gathering some of the 2021 data, but in 2020, about 8.5 million EVs were sold globally, whether it's BEVs or plug-in hybrid EVs. Really, COVID didn't have an impact on EV sales, at least from the surface, compared to automotive sales, which was kind of interesting. I mean, we fully expected, just like the rest of the economy, COVID to massively impact EV growth, but it really, we're showing that it really did not. By 2025, I said that the market for EVs globally was 8.4 million vehicles in 2020. By 2025, the expectation and the projection is that over 36 million vehicles globally will be EVs, accounting for nearly 40% of total passenger vehicles sold. That may be a hopeful projection, but that's a projection nonetheless. And even just anecdotally, you can drive around and you'll see Teslas and Ford EVs all over the place. Just a few terminology pieces here, if you're not aware. BEVs is battery electric vehicle. PHEV is a plug-in hybrid electric vehicle. And FCEV is a fuel cell electric vehicle. Of course, with the adoption of EVs, as I mentioned earlier, comes challenges with grid capacity. The other challenge is the reduction of subsidies by global governments for EV manufacturers, as well as the removal of rebates for U.S. EV buyers. So, for example, China has significantly already reduced subsidies for EVs in 2021 by 20%. And that has slowed the demand for EVs. Like I said, subsidies for EVs in the US end at 250,000 vehicles, but the government is looking to extend that to promote mass adoption.
So thank you, Biraj, for this great overview about the EVs production globally, its regulations. And now I'm gonna share with you a brief overview of the charging stations market. And to understand the market, we need to consider some essential definitions. So we can start with the difference between a public and a private charger. So a public charger is typically the one that is located where the vehicle owners are highly concentrated and park for a long periods of time. So you can find these kind of public chargers on the shopping centers, on the airports, hotels, government offices, and also should be also located along highway corridors. The private charger is any station that is not accessible by the general public. I mean, you can find this private charger at the offices, at the multifamily properties, or charging that has this kind of access just to only the residents or employees that use these specific buildings. I know that these are like very basic definitions, but it is important to know the differentiation of these kind of chargers to understand better the market. Also, we need to consider that there are different kind of powers between the charging stations. We have the AC charger. The AC charger is the one that goes from 0 to 22 kilowatts. We have the DC low power charger that normally go from 0 to 60 kilowatts. And we have the DC high power charger that goes up to 60 kilowatts. We need to consider also that we have a difference between a charging station and a charge point. So a charging station or a charger basically is the appliance that is connected to electrical supply point, that can charge one or more vehicles at a time. And the difference with the charging stations and a charge point is that this charge point is the single point connecting to single vehicles at a time for charging. What is the growth that we are expecting on the charging station globally? So there are different scenarios that can show us a growth for the charging stations, but these scenarios are between the 20 and 25% growth by 2030. And we don't have a clear number yet. Why? Because everything it's gonna depend, or this growth is gonna depend of the rate of the penetration of the EVs in the market. As Biraj will mention, we are expecting to have a high production on EVs, but this can change in the future. So based on the EVs production, also the charging stations are gonna grow globally. And everything it's gonna depend also on the implementation of the government plans or incentives that we could have about this market. So there is a brief chart that you can see on the top around the different incentives globally that each country region are doing around the market. So you can see like in detail, but let's talk about the incentives or the plans that we are having here in the US. So if we go to the next slide, Biraj, please. Thank you. So what are the incentives that we are having here in the US? As you will know, or maybe we are aware that California leads the US market with around 35,000 public charge points. Also New York, Texas, and Florida are offering different kind of incentives to active the growth of the charging stations on these states. Also, the US is giving like a different kind of or are having different kind of targets around zero emissions and creating different kind of programs that can help us to grow the charging market or the infrastructure deployment. And you are, well, for those that are not aware, we have this Bipartisan Infrastructure Law that basically the government is giving 7.5 billion to create or develop a network around the US. And this this law is focused on different kind of incentives by a state. This means for the residentials, they are going to have like different kind of discounts or different kind of plans if they want to make like an installation of a charging station. Also, for the fleet electrification, the government is giving like different kind of incentives and rebates for those that are going to participate on this kind of transition on the electrification part. For community programs, for the local governments, also they are giving different kind of incentives to support the deployment of this kind of charging stations. And well, at this point, by 2021, 2 million of electric vehicles were on the road in the US. And by this year, is expected to well, we expect that this number can be in a double by 2022. We can find one public charging station by 20 EVs in the US today. And we are expecting to close the year with 40 by 2022. This kind of support of the business is based on a formula, and it's gonna depends on how are going to be the different kind of incentives that each state are gonna make around this topic. So everything is related to the plan of zero emissions that each state could have. So the government is the way the government is gonna give like the different kind of incentives or the different kind of money to support the deployment on this charging station market. If we go to the next slide, please, Viraj. So how we are working on these trends that Viraj all mentioned about the growth of the EVs and also of the growth that we are having on the charging stations market. As you can see, we are facing different kind of transitions. Normally, most of the people mention trends, but I would like to say that it's a transition that we are facing on the automotive industry. So we are having this transition, of course, on the e-mobility side. The industry are going to come more connected to the car. So the connected driving that is coming, the autonomous driving that we are going to have maybe in a few years, not yet. It's expected that by 2035, maybe we can achieve the level 5 or autonomous. Also, because the car needs to be or have like more well, the car not necessarily is going to be heavier than today. So the customers are working on different kind of miniaturization or translation from metal to plastic. Also, we're going to share some details on the following slides, but the customers are working on high flow materials to support this kind of miniaturization trends. And of course, the sustainability topic that is becoming more and more important for the industry. So with this transition that is coming, we need to focus our efforts on develop materials that can support this kind of transition. This means high energy materials, high energy density materials for the safety of the person now that the autonomous is becoming more important on the industry. As I mentioned, the miniaturization, also the durability of the materials. These new materials needs to have like better properties to support the life of the vehicle in the future. Because the sustainability is becoming a very important topic on the industry, we need to develop more materials that can be more accessible to the environment or support the environment requirements from the OEMs. As I mentioned, the charging stations are going to have a huge growth on the future, and this is going to give us like a challenge to develop more materials that can support more charging efficiency and speed. And also with the charging station growth, and another market is going to grow together with this market is the energy storage systems. So we need to develop also materials that support the quantity of the energy that it's going to be a storage on the different kind of on this kind of systems or in the market. So for this kind of materials and transition, we are developing materials around flame retardants, thermally conductive, materials that support EMI shielding, different kinds of materials with flame retardant, with flame retardancy, high flow materials to support the miniaturization, materials with high electrical isolation, media resistance. Of course, now with the battery, the high voltage connectors are becoming very important to the market. So we are developing materials with the orange color, and because the efficiency that maybe the charging stations would need in the future, we are continue developing high temperature polyamides. So I'm not going to go into the detail of the properties or materials that we are working now, because now I'm going to open the mic to Adam, that he's going to give us like a great overview of our portfolio.
Sure thing. That's just one slide, because right after this one, we will jump to the material matchmaker, and then we will go again to some materials slides. However, I just wanted to give you a kind of high level of, introduction to BASF plastic portfolio, actually. So you have the list or group of 4 different, I would say, resins. So Ultramid, actually, this is referring to PA and PPA based products. Ultradur and Petra refers to PBT and PET. Then we have an Ultraform, which is POM, and Ultrason, which is PES, PSU, PPSU. And that's the pretty much something we are actually pushing towards Immobility. Again, the list doesn't, this list does not exhaust actually all the materials we are offering to the Immobility market. On the right-hand side, you can see the famous plastic pyramid and see what's the actually tendency right now in order to use a plastic material. So engineering plastics play really a vital role in this development, actually. So you can see that PBT, PET, PA, and POM, those are materials of choice in most cases, actually, and I would say 90% will find in the application, after the material matchmaker. So I'm not going to spend too much time on this. Viraj, the floor is yours for the material matchmaker.
Thanks, Adam. So everyone, we have a new tool that we're really excited to launch, and I will share this window. The name of the tool is called BASF Emobility Matchmaker. So I hope you can see my window. Adam, can you confirm?
Yes, we can see it.
Great, thank you. So this was a tool that was launched just a few weeks ago, and essentially it is the home base for Emobility at BASF. All of the grades specifically developed for e-mobility applications are listed in this website, and it's a really easy to use and intuitive tool. So you want to start on the left side here, and and you can search for materials by application or by properties. So within application, we have a bunch of different applications listed here. I'm going to choose, charging inlet as an example. You can also search for properties and search by the product family, and then whatever flame requirements the material has, as well as by glass fiber weight. We are working to install additional features. So if you want to look for CLTE or tensile mod, you should be able to do that in the future as well. But this is a really easy way to have a starting point. So again, charging inlet. So here you see the 2 recommended grades for the charging inlet application. For example, B3U30G6. It gives you all of the properties related to e-mobility on the right side here. And these generally are selected as the two best options for this application. You can select all results, and oh, for this one, it didn't show all results. Let's try Busbar holder. You can select all results, and you can get a bunch of different results as well. But these are the grades that we've typically seen used in industry and developed specifically for this application, for a busbar holder application. So, you know, this is a public. This is a public resource. You know, anyone on this call can use it. The link to the resource is on the Emobility Matchmaker page of the presentation, and we encourage you to use this as a starting point for your journey into BASF e-mobility related materials. And then, of course, you know, please reach out to Adam or Edna or myself if you have any additional questions, or you know, if there's anything that you don't see here that you would like to see. So I think that should be a pretty quick overview of that. And I'm going to share the presentation again here. Go ahead, Adam. Thank you.
Go to the next one, I guess. 2 more slides. Next one.
Sorry, Adam. I just want. I would like to say it on the last slide. Yeah, thank you. As Biraj will mention, also on this tool, it's a very easy tool to use. It's very accessible for everyone. So also on this tool, we can have like a comparison between the grades that you selected. Also on the website, you can have selection of the properties of the material or the application. I mean, you can see the technical information or the details regarding the properties that you are looking. So this is going to help a lot to the make decision, to the persons that normally take the decision of a material, to see the different kind of properties that the material could have. So you can have like this sheet at the end of your research with all the details that you maybe will need for the analysis of the material or of your material on the application. At the end, also you can download the datasheet, or also, as Biraj will mention, you can be in contact with Biraj, Adam, and myself in case you wanna receive like more details on your selection.
Thanks, Edna.
Go for the next one, Viraj, please. Yeah, this is a kind of a big picture of all the sub-segments you can find on the EV, on the electrical vehicles right now. So I'm not going to bother you with every single one, actually, but I want to make some 2 major comments. Viraj already mentioned about the big change because of we are moving from IC into EVs, actually, but we're gonna have like a big, I would say, substantial change in terms of material selection. So we were able to see the transition from metal to plastics. This is still very valid and very vital. You will see, I will give you some examples later on this one. However, the biggest change we will see in terms of material selection will be the material classification in terms of flammability. The automotive business used to be known because by using just nylon 6/6 or 6 glass fiber reinforced, depends on the applications, you were able to see a different variation related to heat stabilization and so on. So this is still okay, this is still ongoing, but you will see more and more FR, so flame retardant materials in the application. So most of the application here, if you go for the charging infrastructure, so breakers and switches, it's going to be FR materials, at least for today. The same things, I mean, even more, I would say, emphasized, it's going to be HV connectors in this connectors and cable management category. Cable sheeting, cable glands, everything will be FR, or already it is FR. The same thing with the HV battery. Thermal management might be somehow different, and it's going to be kind of reflection of what you can see today with ICE concept, probably we may have even somehow easier demands in terms of mechanical or thermal performance, actually, because the temperature generated by e-motors won't be that high, actually. So this is a substantial change. We're gonna see a lot of FR materials for pretty, 90% of the application, at least for the coming years. It's a safety factor. This is working on process situation. All the OEMs trying to find a sweet spot and to make sure that the safety factor is first, actually, it's secured. However, one little comment again on the traditional materials that, as I mentioned, that the metal to plastic conversion will be, again, very important. I remember myself being in the awkward situation when, like a decade ago, we were trying to poison some American OEMs with the plastic engine mounts. And we were kind of, like a laughing stock, because when we were trying to open the discussion with the, plastic engine mounts, the question is, can we apply the plastic material for the, engine mounts like a V8 or V10 engines, right? It was just laughable, because we were trying just to convert what we have learned in Europe with small cars, the size of the shopping cart, into something that's typical in the US, like a big trucks with V8s or V10s under the hood. However, today, I guess that's going to be like a new entry for engine mounts, plastic engine mounts, because the electrical motors are smaller. So this might be a very good applications for metal to plastic conversion. And I do believe that this is something that we, let's say, reinvigorate this, the metal to plastic, transition again. So this is kind of two major comments. And then you will see a sort of, reflection of those things. I mean, especially about FR in the following slides. Go ahead with the next one, Viraj, please.
Yeah, so Adam, thanks for your comments. I'll head to the next slide here in just a sec, but you mentioned thermal management, and we can have a whole other webinar about thermal management. The essence is thermal management for BEVs was based upon thermal management for ICEs because OEMs wanted to be first to market. Now OEMs are developing unique and brand new thermal management systems from the ground up. So the requirements are different, and they're taking that into account from the starting point. And this is a great opportunity for plastic parts, whether it's fluid and coolant control valves, piping, and other chemical opportunities within the battery pack itself and in charging stations. So thermal management, big change coming in that space as well. Go ahead, Adam.
Sure. We don't have that much time. I guess 10 minutes for next, 5 slides, I believe. Okay. So here you're gonna have some, you're gonna see some examples of the applications that we are dealing today, and we will be dealing tomorrow, actually. So the major subcategories for Immobility are related to EV connectors, BDUs, so battery disconnect units, plugs and sockets, and HV, high voltage housings, right? Whatever it's going to be, it can be like an inverter, for instance. So you can see also, key benefits. In many cases, what we will see, it will be, we will be circling around FR properties. So most of them, the EV connector doesn't say anything here, but I would say it's a kind of default situation you have to have in most cases, the FR material. So what is really needed here? It should be, mechanically robust materials, easy to process. As you can imagine, as also Edna mentioned at one of her slides, miniaturization. So you can see those connectors are smaller and smaller. So material are exposed to much bigger challenge. So easy processability is one of the key elements that it's under consideration right now, and the high flow materials will be the answer to meet this criteria. For EV connectors, especially high voltage collectors, you're going to have more and more orange is the new black. So the materials you can see here, the Ultra Dur B43, 31, it's orange. Then you have a A3U44 G6, which is polyamide 66, glass fiber reinforced FRV0 product. DC stands for durable color. Again, the orange color is not just coloration. The color must withstand a critical conditions like a 140 degrees C or more, and it should stay orange. I mean, it's not going to be orange as the newborn one, but it may have some discoloration. However, it should be easy to recognize. The BDUs, battery disconnect units, I would say this is another, relatively well established market today. What I like about it, this is the working in progress, that the whole new applications development. However, we can see right now a sort of consolidation of the properties or demands related to some of those applications. And video is a good example because we have, as a BASF, developed this application with several customers on several different continents here in the US, in Europe, and in Asia. And eventually, in most cases, we were able to match let's say, product selection around Ultramid A3, X2, G5, G7, or even G10 per customer, let's say, specific demand. So we can see a kind of consolidation around demands, and this will help us, all of us, I guess, to make a good material choice or selection. Plug and sockets, again, flammability, F1, for those who doesn't know the UL 94, some of the standards, F1, it's a kind of outdoor suitability, and then it should be chemically resistance, impact. You can see, because you will be handling this, especially the charging gun. It should be a robust plastic. For HV housing, again, high mechanical performance, and together with the flame retardancy, the materials should be wearable resistance, temperatures, thermally stable, and then again, good mechanical properties. I'm not going to bother you with all the materials you can see on the bottom of the slides. For some of you, it's going to be easy to understand them, to recognize them. But again, from this little slide, you can see that I would say 80% of the product you can see they are FR. Next slide, please. Battery components, the similar situation. You can see again, but the battery disconnect unit. However, you have more different elements that will take you further down with the material selection, with the material choice. So the additional application, it's a junction boxes, busbar holders. This is a very, I would say, attractive and popular application. And as you can see, flame retardancy is across the slide. So everyone is asking for V0 material. In some cases, specific cases, if you have connection with the electronics or electric elements in your application, something what is called CTI, current tracking index, 600. So 600 refers to volts. That's another thing that most of the customers are looking for. So flame retardant materials, and then with the high electrical properties like this CTI. Up to 600 volts. Sometimes, we're gonna see and hear more and more about EMI shielding properties. Unfortunately, it's not like a field where the plastics that we are offering to the market will be the good choice. However, it's going to be like a third party involved in the whole process, actually. So you can change your plastic to be somehow EMI shielded. However, it's not going to be the level that might be useful for the application. So in many cases, the plastic part might be just covered spray, covered wrap with some metal film, metal spray, which gives the EMI shielding. Next slide, please. So this is another example of components. So it's a module structural component. In this case, you can see some elements like a module housing, end plates. And what we found, having this experience already gathered with different customers, one of the good products, really very suitable materials, might be the polyamide 6 or 6 with the red phosphorus as a FR system. So you can see on the right-hand side, you can see the picture of the elements, and then you have a recommended product. So the three first products are PA66 glass fiber reinforced to a different level, actually, because you can see G5, G7, so it's a 25, 35%, up to G10, which is 50% of the glass fiber reinforcement. And those products are just excellent for this kind of elements. And the drawback here is the coloration. Of course, the red phosphorus is just, per definition red, so it can be colored into orange unless you're gonna paint it. However, for this, mechanical structural elements, it's just a very, very good product. So you're gonna have like a decent, very nice flammability. V0 at 0.8 millimeter, it's a market standard. We are getting towards thinner sections. So the last product, which isn't red phos, it's a organophosphorus modified PA6 with 30% of glass fiber. You can see the V0, it's 0.4 mil. I guess it's going to be a new standard. again, miniaturization, this will take place. I mean, it's taking place right now. So you will see more and more this kind of requirements. The CTI, the PLC, refers to the level of the voltage. So PLC 1 is, I guess, 450 up to 599 volts. PLC 0, it's at 600 volts and more. On the left-hand side, properties and the features. So the materials are really excellent in terms of long-term heat aging and hydrolysis resistance, mechanical performance. One of the biggest things about RedFOS FR system formulations is a mechanical performance. I mean, it's not that much compromised like with different FR systems. So halogen-free, it's a still halogen-free. Outstanding FR rating. So the V0 at 0.8 millimeter, it's a current market standard. And we can withstand this fire thirst according to GB 38 or 31, which is a sort of the nickname of the test. It's a bonfire. So you can see that we seem to be very well prepared actually for this kind of applications. Let's go to the another one because the time is running out. Something that already been mentioned before, the charging infrastructure. So that's another field area that we are going to be, or we are already very active in terms of promoting certain materials for application. You can see here a bunch of guts like breakers and switches you won't see on the charging station, but they are actually inside. So we have the products. You will see a kind of some examples of those applications and materials we can offer. So the charging gun, the cover. I guess this might be a very interesting application, especially for materials like the ultramid vision, which is semi-transparent or transparent PA6, where the aesthetics are very important and the scratch resistance. So we are prepared for this application as well, which wasn't really the case in the past. A typical application like the mounting brackets, like housings, charging cables. This is a part of our material offer. Next one. So here you can see the things I just mentioned before. So those guards you won't see in the charging station, like breakers and switches. You have the charging gun, you have the outlets, you have this Igbt housing, busbars again. This is something that we already touched base with seconds ago. Again, it's going to be mainly driven by FR materials. Those breakers and switches, only FR materials. Charging guns, I guess this is kind of a field you can see a different material approach. I guess today as a safety factor, it's gonna be FR or at least V2 materials here. The ultramid vision I mentioned before, it might be excellent application for those some of the elements of this charging guns or outlets or the covers. Then the same story with the charging inlet, mechanical strength, UV resistance, because most of the application will be outdoor, so you have to maintain certain color, certain appearance actually over the years or usage. But again, it's those products. I mean, the first one doesn't seem to be FR, but doesn't matter. Two others are already FR. One is V2, the second one is V0. So you can see it's a kind of big place you can fit with different materials. But again, the FR seems to be like a safety factor for most newly developed applications, and it's going to be like a major driver for us. I'm not going to spend too much time on the other applications. Busbar, I mentioned before, flame retardant mechanical performance was one of the biggest features, biggest issue to cover. So that's why you have this A3X2G5, which is really excellent material for such applications. The next one, please. I guess we're going to have like 10 minutes for Q&A session. And the charging infrastructure, I just, mentioned this charging pile components. Again, I believe it's a lot of inside. It's not like a real charging station, just an example. So what might be like, so FR, performance might be one of the key features. UV resistance, again, a critical element in the puzzles because this is outdoor applications. You have to have a very nice, like a class A surface appearance, very important. So ultramid vision, it's one of our answers to this kind of application. Then you have a solar charging, wireless charging, energy storage. And again, you have the one main motive, it's a FR. So all of these products you can see here, they are FR. You can see a very different approach in many cases. I mean, it's going to be like a polyamide / PBT field to play with. Somehow it might be the step higher. If you recall the plastic pyramid, on the top of it you have a bunch of different products, but one of those resins, it's a PPA, so the ultramid advanced N3U41G6 might be an excellent answer to some of the more I would say challenging or critical applications. Okay. Oh, I guess that was the last technical slide, and just recall, but I believe it's going to be Edna or Viraj giving some feedback on this one. Thank you.
Yeah, thank you, Adam. Well, at the end, we're going to share the slides with all of you. So here you will find all the links that can give you a better idea on which kind of applications and where we are participating on Immobility. We have our Immobility homepage, so you will find all of our applications on it. On this Immobility homepage, we created or we developed a virtual car. So basically, you can click also on the application that you are interested on, and you can know more about the details of it. We are running different kind of webinars from the BASF side. So here on this link, you will find all the webinars that are running around the automotive or e-mobility transition. We have a special website for the battery pack offer. As you will know, the battery is like the key topic of the e-mobility. So we already have like a website for these kind of applications. And as Viraj shared with all of us, we have our Immobility material matchmaker. So there is like a lot of material that you can work through and try to see all of our offer around Immobility.
Okay, well, that was great. To Edna, Viraj, and Adam, thank you for that great presentation. As you can see, BASF has lots of application and technology and experience, plus a lot of different products that they offer. And so what we'll do now is switch over to the question and answer period. The first one comes in and it says, "Hello, BASF team. I'm wondering if the ultramid ultra-dur grades can be used to replace aluminum housings, for example, used for power electronics or even e-motor housings."
Everything is possible. I mean, depends on the specific applications. What are the critical to quality? I mean, all the demands. As I mentioned, we are working on some with one of the leading OEMs here in the US on a new generation of the e-power trains, and one of the ambitions is to replace aluminum inverter housing by some plastics, thermal PAs or PBTs. I guess is going to be PA with some extra features. So yes, I believe that this is a possible solution, but again, every single situation needs to be carefully and individually assessed. Actually, there's no uniform answer to those things, but I do believe that this is one of our ambitions.
Great, thanks, Adam. Another question coming in. 2030 seems to be like the next big tipping point for EV and hybrid sales. There's significant barriers in getting there: charging infrastructure, electrical grid capacity, vehicle distance per charge, and energy storage. Can you tell us which one or two you think will be the hardest for the industry to overcome?
Yeah, I can take this one. This is Viraj. In my eyes, it seems like the adoption of EVs by consumers is quicker than the changes to the electrical grid. Of course, battery materials are going to be a limiting factor. Cost might be a limiting factor. We are potentially going into a recession here as well, so fewer folks are going to be buying EVs, which are not cheap by any means. But hopefully once we get to that point and a larger portion of OEM sales are EVs, they'll be able to hit their economies of scale more easily, and the cost of EVs will come down. But from our perspective, the electrical grid in the US and around the world, being able to support charging of EVs at the same sort of energy level as the number of ICEs that are out there is likely going to be the most limiting, the greatest limiting factor.
Okay, Biraj, thank you. Next question. You talked about weight out, and it's important on travel range of a vehicle. Can you tell us more about your metal to plastic strategy for an EV battery components? And if you're a designer, what are things that you need to be thinking about for ideal applications to convert from metal to plastic?
Sure, I can take this one as well. So metal to plastic is not really anything new, or that initiative is not really anything new at BASF. I mean, our goal for a really long time has been metal to plastic conversion in exteriors, interiors, powertrain, chassis. Adam mentioned engine mounts, for example. So the approach to metal to plastic conversion has not really changed. It's just that the sensitivity has changed because weight reduction is directly correlated to EV range, and greater EV range means less consumer range anxiety. BASF has resources all the way from modeling to processing support at molders to promote metal to plastic conversion. We don't just take a metal part, same design, and say, hey, use this resin instead to mold it, you'll save this much weight. We take into consideration the actual application itself and the applications around it to understand what the true requirements of the part are, and from there build our recommendation from the ground up.
So the old model of molding in features and performance, right, that you can't do with metal is a big consideration, right?
Can you repeat that, please? Sorry.
Yeah, no, I'm just saying, so molding in function and molding in features, combining, function, continues to be a big driver there, right, for the metal to plastic.
Yeah, definitely. And being able to mold in inserts has always been, a part of the consideration when recommending alternate polymer materials to metals. Inserts or the actual geometry of the part, where material can be taken out to reduce weight as well. But plastics, the plastics technology that we're at right now has shown, if given the proper development and modeling support, to be equal, if not superior to metal, given the actual properties of the polymers and the way that engineering services are set up these days.
One thing, it's a design freedom as well. You can let's say express yourself much easier using plastics, because the design freedom is one of the biggest features on the plastic side.
And like you said earlier, you guys have the resources and the capabilities around mold flow and FEA and good correlation, right, that you can have access to and share with your customers and our customers. So
that's right. Yep. And not only do we work with tier 1s and tier 2s to support those kinds of developments, we're working with OEMs to change their opinions of metal to plastic conversion, because there is some hesitation that exists about plastic materials. Like I said, our runway for metals has been many decades longer than with plastics. And we're at a place now where plastics are getting more and more sophisticated, and we're able to, like Adam said, have the design freedom and ability to have the plastic parts perform equal or better than metal.
Okay, one last question here. We got a minute. So the question is, how is BASF prepared to address the requirements for energy storage as it relates to charging stations and capacity? Do you have materials and applications that you can share with customers to give them ideas?
Yeah, definitely. It's something that we can discuss together with the customer. As Adam mentioned, we have been developed different kind of grades for the charging stations and the energy storage systems, everything related to the flame retardancy. So our materials are certified with the UL. So we have been prepared all of our developments and materials to this for these kind of trends that are coming. So if someone is interested in know more about the materials or applications inside the energy storage systems or the charging stations, please feel free to reach out you guys or Adam, Biraj, and myself, and we can give you more details.
Great. Well, I think that's going to put a wrap on this. So from the AMCO Polymers team, we'd like to thank our BASF partners for this great presentation and support. And just to let everybody know that when you registered for the seminar, you'll be getting a copy of this as well. We've taped it. And we encourage you to call AMCO if you've got any questions or BASF. And we just appreciate everybody's time and energy today. Thanks, and have a great rest of your week.
Thank you, everyone.
Thank you.
Thank you, everyone.
Thank you for having
Bye
us.
now.
Cheers.
Please use the Matchmaker. It's a great tool. Thank you.
Thank
Bye-bye.
you.
Bye-bye.
Bye now.